Modern life would hardly be possible without products derived from crude oil. These include fuels and oils for most forms of transport, lubricating oils, and tar and bitumen for road surfacing. Crude oil is also the starting material for a huge variety of organic, carbon-based chemicals and products, such as plastics and synthetic fibres. Most oil refineries are on the coast and have good road and rail links. On this site, 2 crude distillers together process 34,000 tonnes of crude oil per day. There is also a catalytic cracker and a platformer for converting straight-chain molecules to branched chain. On site is a range of storage tanks for the different products. Crude oil is brought in by pipeline to storage tanks. Many of the products from this refinery are used by the chemical industry in the surrounding area. This is crude oil. It's a mixture of different hydrocarbons. The first step in refining is to separate the oils into fractions of different boiling ranges by fractional distillation. The crude oil is first heated by gas or oil-fired burners. This vaporises most of the oil. The vapour is fed into the bottom of the fractionating tower, a column containing over 40 perforated trays. The bottom of the tower is kept at 360 degrees Celsius and the top at about 100 degrees Celsius. The vapours rise up the tower and condense to liquid when they arrive at a tray that is sufficiently cool. The perforations in the trays allow vapours to rise up the tower and liquids to drip down. Liquids, called fractions, are piped off at different levels in the tower. The higher up the tower, the lower the boiling point, and the shorter the hydrocarbon chains. Gases from the top of the tower are used as fuel gases, both for sale and in the refinery. The thick liquid residue from the base of the column may be distilled again under reduced pressure to give further separation. There is more demand for the shorter chain fractions from the initial or primary distillation than for the longer ones. Longer chain fractions are therefore cracked, a process of breaking the molecules to give shorter chain fractions. 10,000 tonnes of petroleum fractions are cracked each day at this plant. In catalytic or cat cracking, the long chain fraction is mixed with a powdered catalyst of silicon dioxide and aluminium oxide, and the mixture enters the reactor at about 500 degrees Celsius for 5 seconds. Here the cracking takes place. The catalyst becomes coated with carbon and is recycled. The catalyst passes to a regenerator where the carbon is burnt off in air. The products of cracking include alkenes. These are hydrocarbons with reactive double bonds. They are vital starting materials for chemical processes such as polymerization. Valuable short-chain alkanes for petrol are also produced. After fractional distillation and cracking, fractions may undergo further treatment, including desulfurization to remove sulfur, which would produce sulfur dioxide when the fuels are burnt. Platforming, in which straight-chain alkanes are converted to branched-chain alkanes by heating over a platinum catalyst. The branched chains produce better quality petrol. Fractions are also blended, mixed to give products of the required properties for use as fuels and lubricants. The products are transported off-site by road, rail, sea and air.